Welcome back. In this episode, we're going to be talking about Matplotlib and data visualization in Python. Now, there are a lot of different options for data visualization in Python, and Matplotlib is one of the older ones, but it's very, very widely adopted, and it actually underlies a lot of the other libraries that exist out there. It's designed to act a little bit like MATLAB, if you're familiar with that, but we're going to cover the basics. Now, this episode might be a little bit dry because Matplotlib is a little bit dry, but it's going to build us up the skills that will let us visualize some cool things. So, in order to do this, we're going to import a specific module called pyplot from the Matplotlib library, and we're going to import it as PLT. This is just kind of conventional. Now, what I'm going to be showing you in this episode, you can take a look at the pyplot tutorial. A lot of it's going to be covering the tracks that they made there. But if you want to stay and work through this with me, I'd really like that. So to start off with, we can plot a line. So what I'm going to do here is I'm just going to create a list of integers from 0 to 18. So I'm just saying I times 2 for I in range 0 to 10, just for fun. And this is going to be 0, 2, 4, 6, and so on and so forth. And I'll print that out so you can see what that looks like, and then I'm just going to plot it. The nice thing about Matplotlib is if you do plt.plot and give it a list of integers, it's just going to plot a line. And in order to be able to see anything, we're going to have to call plt.show. So let's go ahead and run this code. So Python 21 viz 1 line. OK, so what we can see here is this is printed off 0, 2, 4, 6, 8, 10, so on and so forth, and it's plotted a line for us. Now notice the x-axis here are the indices of the list that we gave it, and the y values are the values in this column. We, of course, can get much, much fancier. We'll look at the next piece of code, which is plotting 2 lines. So now, instead of just plotting a single line, if I have my data, which is the same as before, and my data 2, which is the same as before, except instead of multiplying by 2, I'm dividing by 2, if I call plot.plot my data and plot.plot my data 2, it's just going to put both of these lines on the same plot. And I'm going to call plot.show to see something. So if I run this, we can see that, hey, now I have 2 lines on the same plot. Now, one of the really important things that you need to know when you're creating visualizations is you should always label the plot itself, give it a title, and your axes should be labeled. So here what I'm going to do is I'm going to go ahead and plot that data, and now I'm going to call a few extra methods that will add information. And you have to do this before you call plt.show. So here I'm saying plt.title, useless data. I'm saying plt.ylabel is data, and plt.xlabel is index. So when I run this, oh, close that. Now run this, Python 21.03. What we can see is now I have added a title to the plot. I've added a data label to the y-axis and an index label to the x-axis. So this is an important practice that you need to remember to do so people can interpret the visualizations that or the graphs or visualizations that you're creating. If we look at the next piece of code, if we're building a complicated visualization, often what we'll want to do is we'll want to save it to disk, maybe edit it in something like Adobe Illustrator, or just put it on the internet or email it to friends. In order to do that, instead of calling plt.show, what we call is plt.savefig, and inside parentheses we give it a file name. Now, the file extension that you give it will determine the file format. I prefer to use .pdf because then I can take this, whatever I generate in Matplotlib, and make it look a little bit nicer using a different program. And by doing it in PDF, it saves it as vector formats, so it's much easier to work with. Plotting a line like this isn't particularly useful because it isn't letting us specify what the x values are. if we want to specify both the x and the y values, what we can do is we can give it two lists. One list has the x values, and the other list has the y values. So here I'm just creating two lists of data, my x values, which is just 20 to 29, and my y, which is just 10 to 0, walking backwards. Now, remember that these two lists should always be exactly as long as each other because they're x and y coordinates, and you can't have an x without a y coordinate. And so what I'm going to do here on line 8, just for fun, is I'm going to change the item at the index 4 to 12, just so it's not a straight line. And I'll go ahead and plot my x, comma, my y. So now what it's going to do is it's going to interpret this as x and y values to plot a single line according to the data that we fed it. Now we have a title new lines, x values, and y values. So I'll go ahead and I'll run this. 04. Oh, that's 05. I didn't run 04 because all it's doing is creating a file, which I don't really need to do. And here we can see that now we have a new line where it runs down from 10 to 7, jumps up to 12, jumps back down to 5, and down to 0. Now notice that Matplotlib will actually try to guess what the best axes are for you. So here this is 0 to 12, and here this is 20 to 28. We can also take this same data, and instead of making a line plot, we can make a scatter plot. And here, the only difference is, instead of calling plot, on line 10, we call scatter. And now it's a nice scatter plot, so each data point is represented by a circle. So I'll run that again, or rather run the next one. 06, scatter. And here we can see now we have a scatter plot instead of a line. And this is useful to do if your data isn't continuous, if there's no meaningful connection between these points. If the intermediate values don't make sense, sometimes this is a nice way to represent your data. Now you can change the size and the color of all of these different points. So if we look at the next piece of code, what we can do is when we're creating this scatter plot, we can give it a few extra values. We can say size equals 100 and C equals magenta. So the only thing that's changed are these keyword values. And I'll go ahead and I'll run the next one. And this is 7. And we can see that now the size is 100 and the color is magenta. We can, expand this and look. I should also point out that down here you can click this disk button to save it, or you can zoom in if you want. This is a handy thing if you're exploring some data. But the next thing we might want to do is we might want to individually control the size and color of these points. And this is useful if you need to add extra information about who wrote a particular text or how long a text is or whatever. We can take a look at this. So here what I'm going to do is I'm going to add a list of colors for the points. Now these colors can be words, they can be anything I believe that is specified in CSS5. They can be red, green, blue values or hex values. Here I'm saying blue, magenta, black, blue. FF00FF is a hex value, 0.8. So 0 is going to be black and 1 is going to be white. Green. And I'm also going to provide a list of sizes. So 100, 50, 80. And now note, I need a color and a size for each data point that I have. And now, instead of giving it a single value, I can give it a list of sizes and a list of colors. When I do this, I'll go ahead and run it. 08. And we can see that all of these different dots are different sizes and different colors. We'll see in a little bit how we can use this information to actually convey data as we work with real live examples. So we'll close this. Whoops, cancel that. We'll close that. And we'll move on to talk about how we might make a subplot. So what if instead of plotting those lines on the same plot, I wanted to have two plots in the same window? Well, that's actually quite easy. Here I have two different lists of data, and I'm going to create a figure object. So by calling plt.figure, I'm creating this object that's going to hold all of my different plots. To add a subplot, what I can do is I can take this figure object and add subplot using this function, and I'm going to give it 3 data points. I'm going to say 2, 1, 1. Here what I'm doing is I'm saying there are 2 subplots, and I'm going to start by working with the subplot in column 1 at row 1. Okay? And I'm going to save this as the variable subplot1. Now what I need to do is to actually use this subplot, I'm going to go ahead and plot my data, and I'm going to just change things up. I'm going to add a line style. If you go to the documentation for Matplotlib, you can see all of the different styles of lines you can add. And then on this same subplot, I'm going to go ahead and draw that other data using the draw style steps. We'll see what this looks like in a second. Then what I'm going to do is I'm going to add another subplot using add subplot. And this time I'm saying there are 2 total subplots. In column 1 on row 2, add this subplot 2. Okay? Then I'm just going to do the exact same thing, but instead here I'm going to say data 2, make it line style dashes, and the draw style of data 1 is steps. And then I'm going to plt.show so you can see what's going on. So what we can do is run that, and we can see now I have 2 plots on the same graph. So I have all of that data, but I've just mixed up their drawing styles so you can see them in a little bit different of a light. Now, as I mentioned earlier, you should always label your plots. And you can do this with these subplots, basically in the same way that you did it earlier with your larger plot, but the calls are slightly different. So here what I'm going to do is I'm going to create all of the plots, but now, once I get down to line 26, I need to set the title for the subplot 1, and I'm calling it numbers. And subplot 2, I'm going to use the same function called the same method called setTitle more numbers. Okay? So instead of just plt.title, it's subplot.setTitle. Okay? And you'll need this when you're working with these subplots. You can also add x and y labels with set x labels and set y labels. You could also limit the number of ticks with set ticks, or set x ticks, set y ticks. This way you can kind of control what numbers are being shown in your plot. So what I'm going to do here is I'm just going to go ahead and set my y tick labels equal to letters just for fun. And I'm going to set the rotation to 15. And we'll run this. So Python 21, 10. So now you can see that we have numbers and more numbers. And we also have in subplot 1 these B, C, D, E, and so on and so forth. You'll notice it actually dropped off the A here because that A is at 0. So you have to be a little bit careful when you're working with these to make sure that you don't let data get dropped off. So the next thing that you might want to know how to do is how to make a bar chart. The way that we graph lines and scatter plots is a little bit different than we do bar plots. So let's go and let's take a look at this. And we can see that it's relatively easy, but it requires a slight adjustment in our thinking. So here I'm importing NumPy so I can generate a little bit of random data, and I'm just saying, give me a random integer between 0 and 20. Give me 15 of them. And then what I'm going to do is I'm going to create a plot. And here I'm just going to say my plot equals figure add subplot 1, 1, 1. This isn't strictly necessary because, of course, you don't need subplots if you're only using one. But to make a bar chart, I need an index. So what I'm going to do is I'm going to say I for I in range, the length of my data. So this is just going to give me 0, 1, 2, 3, 4, up to 14. And this is going to act as an index that I can use to create this bar chart. It's a little bit weird, but you'll get the hang of it the more you practice with it. Then what I'm going to do is I'm going to take myplot.bar index, comma, data. So I'm giving it the index and then the data. And then I'll go ahead and plot that. So we'll do Python 21, 11, bar chart. And here you can see that it's a nice little bar chart with the indices along the bottom and the values on the y-axis. If I close this and I run it again, you'll see that these numbers change because I'm generating random values. But that's how you make a bar chart. The last thing that I want to talk about when it comes to Matplotlib, and we'll see this more as we do actual analyses, but is a nice little library called Seabourn. Now, Matplotlib has been criticized by some as looking a little bit old-fashioned, and that's fair. If you want to make things look a little more modern, you can use the Seabourn library. If you import Seabourn as SNS, this is just kind of a standard way of doing it, you can just call sns.set and then do the exact same thing, except now we're going to use sns.barplot index data. So the only big difference is we're going to set the style using Seabourn, and we're calling Seabourn's barplot instead of Matplotlib's. And this is just a wrapper for Matplotlib that's going to make it look a little bit nicer. Here, what I'm going to do is I'll just go ahead and run this, 12 Seabourn, and we can see this is actually going to be in a style that looks quite a bit different, maybe more aesthetically pleasing, kind of depends on what your preferences are, but it's a little bit easier to read, more modern looking. So that's a really quick introduction to Matplotlib and Seabourn. There are many, many more things you can do with this, and this just scratches the surface. But with more and more practice, as you start to actually visualize data, it'll start to let you create some very nice data-driven plots. So in the next episode, we're going to get into some real stylometric analysis using all of these different concepts that we've learned up to this point. So I hope you'll join me then, and I'll see you in the next episode.